Hello, Saving Grace Homeschool. I'm James, and today we're doing a lesson looking at whole numbers, addition, and subtraction. I'm not too sure yet. I might split this lecture up into two videos. We'll see how we go. Whoops. Okay. So let's look at some mathematical background. Calculations with multi-digit numbers are done by breaking the task down into separate, smaller tasks. For example, the single task, 254 plus 538, can be broken down into smaller tasks as follows. So the 254 can be broken down into 200 plus 50 plus 4. And the 538 can be broken down. So the 538 can be broken down to 500 plus 30 plus 8. And then you group the hundreds together. So you would group the hundreds together. Then you group the tens, and you add them, and then you would group the units together and add those. Okay, and this rearrangement can be done because addition is commutative and associative. So then when you add the hundreds, the tens, and the units all separately, you get the hundreds will give us 700, the tens give us 80, and the units will give us 12. And when we add those together, we get our final answer of 792. So that's just a way to break up this question and to make it slightly easier to work with. The second and third columns above show two different ways in which exactly the same thinking or method can be recorded in writing. So where's the second and third? I'm not too sure what they mean, the second and third column. Anyway, I hope you guys know what they mean there. Okay, let's carry on. Learners can only use breakdown, rearrange, and build up methods effectively if they are fluent in mental arithmetic, i.e., if they know the addition and subtraction bonds for units and multiples of tens and hundreds well, or can quickly reconstruct these facts. It is critical to understand that the vertical column notation is just a different way to set out the work for the same method of addition that learners have been using up until now. The mathematical thinking involved is exactly the same. Okay, so I think what this means over here is that what happens here is exactly the same as what is going on here. This is just a quicker way to do it. And yeah, so it's just a quicker way, and then you have to break it up all into separate things like this. And then the resources for this section are calculators and place value cards. So let's just go through this quickly. I'm not too sure if you guys have done long addition like this, the long method of addition. I'm sure you have at some stage, but let's just go through it anyway. So how this works is, it's exactly the same, sorry. So this is the long addition. So it's still broken up into the 200 plus 500, the 50 plus 30, and the 4 plus 8. And then when you add those up, you'll get the same answer of 792. There's also a short method that we'll get onto later. Basic addition and subtraction facts and skills. Addition and subtraction relate to different problem types or different kinds of situations in reality, including the following. So there's summation. For example, adding the lengths of 3 types of fencing described in the shaded passage. Okay, so we'll get to that just now. There's increase and decrease. For example, the removal of 580 meters of the 1,572 meter fence described in the shaded passage. Okay, so that would be a subtraction. And the comparison of difference, comparison by difference with reference to the shaded passage. You may ask learners what the difference in length of the type A and the type B fencing along the stretch of road is. So that would most likely be subtraction as well. Awareness of the different problem types can strengthen learners' capacity to engage effectively with word problems. For example, learners who think of addition only as making more or increase may not realize that addition is required in a situation that requires a summation. Learners who only think of subtraction as taking away or a decrease may not realize the difference between two quantities can be found by subtraction. So here's a key word in subtraction that pops up quite often: difference. So just a quick side example, if this is, let's say, your older brother, and this is you, boy or girl, I'm not sure if this is a co-ed school, anyway. And they're asking, what is the difference between the heights? Then when you see the difference, often it means you're going to do a subtraction. So you'll take this height. So we'll take height A. And here's height B. That's you. And then to find the difference between your brother's height and your height, you would go A minus B. So when the word difference pops up, it often means a subtraction, subtracting the smaller value from the larger value. So there it says there, difference between two quantities can be found by subtraction. Note that the text in the second part of the shaded passage deliberately moves from the decreased meaning of subtraction to the difference meaning. And let's look at some teaching guidelines. The shaded passage can be used as the basis for a teacher-led class discussion to help learners to relate addition and subtraction to different problem types or different kinds of situations in reality. So here I gave you an example of a situation in reality, how they could ask a question. So that's when the word difference could be used in the question. And then you have to know that difference might relate to subtraction, or most likely will relate to subtraction. To help learners engage with the context, you may make a rough copy of the diagram of the fence on the board. Question 1 serves as a diagnostic activity to provide you with an opportunity to get a sense of the level of learners' basic addition and subtraction knowledge and skills. It may be given as a baseline assessment for learners to hand in. If learners do not perform well, this can be used as motivation for the work that follows. Okay, so here are the questions. So there are 486 meters of type A. So this is 486. 723 meters of type B. And 363 meters of type C. Fencing alongside a certain stretch of road. Okay, so these are the three different types of fences, and they're all of different lengths. Altogether, this is 1,572 meters of fencing. And how we get that is we add all of these together. So if we add these, we'll get the total length of the fence, and that will give us an answer of 1,572. And then we can say that 1,572 is the sum of 486, 723, and 363. If 580 meters of this fence is removed, okay, let me just erase this quickly. These addition signs, plus signs, okay. So now we move on to this question. So if 580 meters of this fence is removed, there will be 992 meters left. We say that the difference between 1,572 and 580 is 992. So what this is, it is the total. So remember, we added them all up and we got the sum, which was 1,572. And if we take the total length of fence and we subtract 580, then we can find the difference between the total length of fence and 580 meters. And that gives us 992. And then here are some questions for you guys to calculate. for question 1, and here are the answers over here. Okay, let's move on to the next page. Notes on questions. Questions 4b and 5 are intended to strengthen understanding of the link between addition and reality. The questions serve to highlight addition as summation, which is a different meaning of addition than increasing or adding on. So we always think of addition as just adding on, but it also can be thought of as summation in problems that are linked to reality. So a lot of the time they won't just say 12 plus 3. They'll give you a real problem and they'll say, I don't know, if you have, or if you like add some fence to another fence, like the previous problem, that would be summation, which is still essentially the same as adding on. It's just a different way of thinking of it. This is important because learners sometimes have a limited view of addition as only meaning to make something bigger by adding on. Then here are the teaching guidelines. If learners have difficulty in reading the lines in questions 3 to 5, you may tell them that the blue and red colored sections all consist of 10 spaces each, i.e. units of 10. Okay, so for example, I can't really see how many lines there are here, but we've been told that each of them have 10. So this would be 10, this would be 10, and then the same in red. So if you can't see how many lines there are, you can assume that there are 10 because we've been told that. Note that the acquisition of mental mathematics, or the knowledge of number facts and skills to produce number facts, and the development and strengthening of number concept go hand in hand. Good number concept contributes to good mental mathematics and vice versa. So then it says here, the number name for 1600 is 1600. The name 1600 can also be used. So in South Africa in general, we would say 1600. It's not very common to say 1600 in South Africa. It still is correct, but usually we say 1600. So to calculate 1600 minus 700, you may think of it as 1600 minus 700 instead of 1600 minus 700. And then if you think of it in hundreds, then you can just ignore the 100 for a second. And then what is 16 minus 7? It would be 900. And that would be the same because then you would have to add the hundreds back. So it would be 16 minus 7, which gives us 9. And then if you add the hundreds again, so we erase this now, then we would get 900. What is the number that is missing from each of these number sentences? Okay, I'm going to leave these questions up to you guys. Remember, if you can't see how many little lines there are here, we've been told that there's 10 of them. Teaching guidelines. The short shaded passage serves as an example for question 6. You may alert learners to the commuted versions of 8,000 plus 1,000, 7,000 plus 2,000, etc., and state the commutations need not be repeated when answering question 6. Some mathematical notes. The number line provides a way to visualize numbers and operations, and may hence help learners to keep track of their own thinking. Note that the number line can be used in 2 different ways as a visualization of addition. For example, 8 plus 7. So over here, if we have 8 as this number here, and then if we add 7, 1, 2, 3, 4, 5, 6, 7, we'll get to this number over here. Okay, just hang on. Let's read this. Addition as an increasing addition as increasing a given quantity. Example, putting 7 eggs in a basket that already contains 8 eggs. So here we are adding 7, and here we have 8 over here. And if we add them, we'll go 9, 10, 11, 12, 13, 14, 15. So we'll get to 15 over there. Or addition can be looked at as combining two quantities. Example, calculating the total number of learners in a class with 8 girls and 7 boys. So this is the adding on example, increasing. And then this example over here, combining, is the summation that we were speaking about earlier. Some possible misconceptions. When mental calculation techniques are explained by means of diagrams and written representations, as in the shaded passages on pages 27 and 29, so here's page 27, or on the board, learners may form the false impression that they are required to apply these techniques in writing. Impress on learners they should try to apply these techniques without writing. In other words, they should apply the techniques mentally. Okay, so let's look at the shaded passages. So 9,000 can be expressed as a sum of thousands in 4 different ways. So one way it can be expressed is 1,000 plus 8,000, or it can be expressed as 2,000 plus 7,000, or it can be expressed as 3,000 plus 6,000, or it can be expressed as 4,000 plus 5,000. Now we are asked to express each of the following numbers in 4 different ways as a sum of hundreds, thousands, 10,000s, or 100,000s. So that means it's dependent on the question. So for question A, we're going to express it as how many? 4 different ways, summing in 10,000s. This is for question A. And then question C, for example. No, what is this? Question E. Question E, we would look at the 100,000s, because we have 100,000s here, and you need to find 4 different ways, remember. It is easy to know how much 8 plus 7 is if you think of a number line. You can describe your thinking like this: 8 plus 2 to get from 8 to 10, and then 10 plus 5, which is the remaining part of the 7, add 5 over there, because now you've added 2 already. So now you just add the other part, which is 5, and then you get from 10 to 15. You need not draw a number line, just think of it. So yeah, you can just think of one in your head. You can work in the same way with bigger numbers. For example, to know how much 80 plus 70 is, you can think of it like this. So you can add 20 to 80. So if 80 is over here, 80, and then if you add 20, so this is the adding 20 part, and then if you add another 50 over here, because these combined gives us a 70 that we're adding to the 80, and then we go 80 plus 20 goes to 100, and then 100 plus 50 goes to 150. So we can think of the number line in our heads and get the same result. To know how much 8,000 plus 7,000 is, you can think like this. So here's 10,000 there, and here's 8,000, and here is 15,000. And then we would add 2,000 to get to 10,000, and then we would add 5,000 to get from 10,000 to 15,000. And then we could do something similar for 80,000 plus 70,000. You get the idea. Notes on questions. Questions 7 and 9 are designed for learners to take responsibility for their own learning. Learners are asked to identify which of the calculations they cannot yet do quickly, and then spend some time to do the calculations in question 8 to 9. So here are the answers for question 7, 8 to 9. Teaching guidelines with respect to word problems. A major reason why learners often underperform when they tackle word problems is that they do not try to understand the described situation before deciding what calculations to do and or writing a number sentence. So this is very important. You need to understand exactly what the question is asking. Because if you don't and you get confused, so let's say they say something like, remember that example I went over earlier with the difference between your brother's height and your height. And then let's say you don't understand the question properly and you think, oh, okay, they want to find out the difference. And then you know brother's height is A and your height is B. And then you read the question, you don't understand it properly, and you think difference means adding. So you write A plus B is equal to something, and you give an answer, and then you've made a mistake because you have failed to understand what the question is actually asking. So before deciding what calculations to do or writing a number sentence. So it's very important that you spend some time, spend most of the time on a word problem, I would actually say, figuring out what the question is asking you, and then you will spend less time actually answering the question with the maths. So if you know the difference, remember difference means subtract. So we want to find the difference between our brother's height and our height. So A minus B will be the answer, is equal to something. Okay. Encourage learners to spend some time reading the description of the situation and trying to understand it before trying to get an answer. A rough sketch may often help learners to develop an understanding of the situation. Drawing a rough number line can often be very useful as a support for interpreting a problem situation. So just a quick note on sketches as well. So you see I drew a sketch here, and you don't have to spend a lot of time with the sketch. You just need to make it obvious what's going on. So you don't need to like put clothes on the stick pen or anything ridiculous. Just make it as quick as possible, just so you can visualize what is happening with the question. Where are we? While this may take up much time at first, it is a good investment if learners develop the habit of engaging thoroughly with the given problem situation before trying to produce the answer. So that's what I was saying earlier. Spend more time trying to understand the question and maybe draw some images, like draw some sketches, stuff like that. Then spend time quickly trying to answer it and then having to go back because you've made a mistake. The following are two other very useful habits that will increase learners' proficiency at solving word problems. So one of them is the habit of estimating the solution before doing any calculations. So that's very good. If you know kind of what the answer is going to be, then you can figure out the answer exactly. And if it's in the correct kind of range, then you know you've done the question properly. And the other one is the habit of checking the answer once the calculations have been completed by checking whether it makes sense in the real situation. Okay, and then here are the answers for questions 10, 11, 12, and 13. And here are the questions. I'm not going to go through these questions with you. You have the answers and you have the skills to answer them. Mental calculation techniques. Critical knowledge and skills. It is critical that learners are able to reconstruct basic number facts they cannot recall. Otherwise, they will consistently resort to the time-consuming practice of drawing stripes and counting, which will inhibit their progress in mathematics enormously. So what this is saying is, if there's something and you need to do a quick calculation like 15 plus 8, don't know why I drew my 8 like that, plus 8, and this is only a step in the final question, you can actually get slowed down a lot if you have to use your fingers and go 15, 16, 17, 18, 19, 20. If you just know straight away, boom, it's 23, then you've saved a lot of time and you can move on to the next step in the question. Okay, moving on. To be able to form facts that they cannot recall, learners need ready knowledge of some addition, subtraction, and multiplication facts. Okay, so like the one I just showed there, 15 plus 8 is 23, things like that. So like not the obvious ones. So there are obvious ones that will be really easy to calculate in your head, like 15 plus 5, for example. We know that's 20. That's quite an easy addition fact. And then we should know the multiplication tables up until 12, I think. That's what I got taught at school. I'm not sure what you guys got taught. So those you should be able to recall reasonably fast. And then move on to the next step, knowledge and skills to quickly form new facts from known facts. So let's go back to this quick example. It's a really small example, but 15 plus 8. And then remember, I also said we would know an easy one like 15 plus 5, right? So we know that is 20. I hope you guys know this. It's not too difficult. It's quite a straightforward one. But 15 plus 8, it looks slightly more complicated. But what can be done is it can be broken up. You can do this in your head. The point of this is to do this in your head, not write it down, because then it's still taking up some time. Okay, plus 3. So now we have the exact same thing. We have 15 plus 5 plus 3, because 8 and 8 can be broken up into 5 plus 3. So then we have, know that this is 20 from down here. 15 plus 5 is 20, and then we add the 3 to get 23. So if you can do things like that in your head to break things up, it makes things quite easy. So that's just knowledge and skills to quickly form new facts from known facts. So here we have a known fact. This one, we have a known fact, and then we can form a new fact from this known fact. That's what it says there. For example, a learner may have to calculate 344 plus 557, but may not immediately know how much 40 plus 50 is. If this learner knows that 40 plus 40 is equal to 80, he or she can find the value of 40 plus 50 by adding 10 to 80. Okay, that's exactly what I've shown here. They just have a different example. So let me actually just go through that just so you guys understand that properly. I'll use the same colors even. So we have 40 plus 50 over here. And then down here, we have 40 plus 40. And we know that this is 80. And then this can be broken up into 40 plus 40 plus 10, because this would give us 50. These two equal 50. This is the 10. You can't really see the 1 there. And then we know this fact already. 40 plus 40 is 80. So we have 80 plus 10, which gives us an answer. So 80 plus 10, which gives us an answer of 90. Okay. So now you know how you can use known facts to quickly calculate unknown facts or new facts. Ensure that learners understand why they need to be fluent in mental calculations, i.e., why they have to know some basic number facts by heart and be able to quickly and without writing produce the answers in cases where they do not recall the facts. The reason that if you cannot do the calculations with the place value parts quickly, a calculation with multi-digit numbers becomes a long and tedious process. You may demonstrate this by doing a calculation on the board. For example, 4,386 plus 3,569. If you do not know quickly that 6 plus 9 is equal to 15 and 80 plus 60 is equal to 140, it will take you a very long time to calculate the whole calculation, 4,386 plus 3,569. So it's just better just to know these number facts. So I'm sure you guys already know some tricks. If you're adding something to 9, the answer will be the same. So not the same, but it will go, you'll obviously go up a digit here. You'll get a tens unit. Tens unit will go up 1, and then whatever this one is will go down 1. I don't know if that makes sense, but let's say you're adding 23 plus 9. Then the tens units will go up 1, so that will become a 3. And then the units one will go down to become a 2. That's not very well explained, but I hope you know that rule anyway in your head. I don't know how to explain it properly in words, but yeah, it's quite a simple thing with 9s to do. Learners who do not accept the challenge to learn and do calculations reasonably fast cannot appreciate the need to be able to do mental calculations fluently. Mental calculation techniques. So now we're looking at here. And here are the answers for question 1, 2, and 3, by the way. If you know that 8 plus 5 is equal to 13, you also know that 8 tens plus 5 tens is equal to 13 tens. In other words, 80 plus 50 is equal to 130. So all that's going on is we just have zeros at the end of that to make that calculation true. In fact, you also know that 8,000 plus 5,000 is equal to 13,000. In other words, 8,000 plus 5,000 is equal to 13,000. And then 80,000 plus 50,000 is equal to 130,000. If you know an addition fact, you can always make 2 subtraction facts from it. For example, if you know that 8 plus 5 is equal to 13, you also know that 13 minus 5 is equal to 8, and 13 minus 8 is equal to 5. So that's just rearranging this to get 2 subtraction facts. You then also know the following subtraction facts and more. Okay, that's related to these ones. So this is related to this one, and this one is related to this one, I think. No, sorry. 13,000, there you go. So this is related to this one. Yeah, and there'll be other subtraction facts as well, because it says that there are 2 subtraction facts for every addition fact. Use the fact that 7 plus 8 is equal to 15 to give the answers for the following. Okay, so these are questions for you guys to do. And then use the fact that 9 plus 6 is equal to 15 to write 5 other addition facts and 5 subtraction facts. If you know one fact, you can easily make other facts. An easy way to make a new fact from a known addition fact is to transfer parts of one number to the other number. For example, if you know that 30 plus 90, just get a better color pen, 30 plus 90 is equal to 120, you can make new facts as shown below. So if we go 30 plus 90 is equal to 120, we also know that 300 plus 900 is equal to 1,200. And then if we move 100 from 900 and put it on the 400 and on the 300 to make it 400, then we get 400 plus 800 is equal to 1,200. And we can do that same thing again. We move 100 from 800 to 400 to make this 700 and this 500. And we get 500 plus 700 is equal to 1,200. So it's very easy to make other addition facts. Start with 700 plus 700 is equal to 1,400 and use the above transfer method to form 5 different addition facts. So you're going to use the method above where you would transfer 100 across. So the first one I'll give you, it'll be 600 plus 800 is equal to 1,400. Here's another way to form new facts from a fact that you know. For example, 600 plus 600 is equal to 1,200. So here we have 600 plus 600 is equal to 1,200. So that's what we started off with, this line here. And then if we add 100 to both sides, then we'll add 100 to this 600 on the right here to get 700. And then we'll add 100 to the answer to get 1,300. So a very important rule with an equal sign, whatever you do to the left-hand side, so if you add something to the left-hand side, you also have to add it to the right-hand side. If you subtract something to the from the left-hand side, you also have to subtract it from the right-hand side. That's how the equal sign will remain true or keep the equation true. This may be called adding on both sides method, or add on both sides. Okay. teaching guidelines. Questions 4, 6, 7, 8, and 9 provide practice in forming number facts by starting with doubles. Encourage learners not to focus only on addition with an answer of 1,600 when they do question 8, but also sums other than 1,600 that can be formed by starting with 800 plus 800 equals 1,600. For example, 800 plus 900 is equal to 1,700. So this is the adding on both sides method that happened here. Before learners do question 8, it may be helpful to demonstrate how subtraction facts can be produced from addition facts. For example, if you know 800 plus 900 is equal to 1,700, you also know that 1,700 minus 800 is equal to 900, and 1,700 minus 900 is equal to 800. So that is just rearranging this equation here to get these different equations. So that is what has gone on over there. Then here are the answers for questions 4, 5, 6, 7, 8, and 9. Okay, I'm not going to read through the questions on this page. I'll read through the shaded section because that is usually the important thing that teaches us something. The doubles are easy addition facts to know. For example, 30 plus 30 is equal to 60. And 4,000 plus 4,000 is equal to 8,000. We can also say 3 tens plus 3 tens is equal to 6 tens. And 4,000 plus 4,000 is equal to 8,000. So that is the doubles. If you want to know how much 3,000 plus 5,000 is, you can start with the nearest double. The lowest double is, so you can double the lowest number. That is usually the convention, because if you double 5,000, it might make it slightly more complicated. So if you take the lower number, which in this case is 3,000, and you find that double, you get 3,000 plus 3,000, which gives us 6,000. And then we add another 2,000 to the 3,000 to get 5,000. So we just add 2,000 to 6,000 to get 8,000. So let me just write that out in full here. So we have maybe a bit smaller, just that much space, 3,000 plus 5,000. Okay, and how this can be done is using doubles. So you take the smaller number in most cases and you find that double. So 3,000 plus 3,000 plus 3,000, we know that is 6,000, okay? And then we can use that. So we can take this part of the question over here. Oopsie. Just bear with me. To get. Okay, so we know this. This is the doubling of the lower number, which is 3,000. And if we use that, we get 3,000 plus 3,000 plus 2,000, because 3,000 plus 2,000 will give us 5,000. So then we'll still have 3,000 plus 5,000 like it is there in the original question. Then we know that all of this is equal to, write our equal sign over here as well. All of that is equal to 6,000 because we know the double. 3,000, 6,000 plus the 2,000 that was left over from the 5,000. And then we get our final answer of 8,000. So that is what is happening here. Okay, let's move on. Notes on questions. Question 10 draws attention to finding a difference as one of the meanings of subtraction. This avoids limited understanding of subtraction as being only taking away or making smaller. For example, I have 10 marbles and give 3 to my friend. How many marbles do I have left? So that's a taking away example. Or we can calculate a shortfall. For example, John wants to buy a toy that costs 50 Rand, but he only has 30 Rand. How much money does he need to buy the toy? So that is a shortfall, but another way it can be phrased is finding a difference. So that is another way that subtraction can be said in a question. The technique of filling up, so when you look at the shaded passage, shows how to use a shortfall in subtraction. Learners may be challenged by question 10. You may suggest that they make a drawing to show Jan and Tebogo's positions at 30 meters and 45 meters from the starting point. In some teaching guidelines, for the sake of speed, it is important that learners learn to calculate with as little writing as possible. In other words, that they can do some calculations, example calculations like those in questions 11 and 12 mentally, but without writing. And then to do calculations with multi-digit numbers with as little writing as possible, for example, by using the vertical column formats for addition, subtraction, and multiplication. Okay, so it looks like you guys have learned these short addition, subtraction, and multiplication methods. While there are still learning techniques for doing calculations mentally, for example, to think of movements on the number line and filling up multiples of 10, 100, thousands, thousand, and higher powers of 10, learners may have to write and make drawings. In these questions, learners should draw number lines quickly, freehand, without using a ruler. So don't worry about neatness, just draw them quickly, and just so you can see how the question can be done and help you to visualize it. However, when learners have completed questions 11 and 12, you may give them some more similar calculations. For example, 8,300 minus 700 is equal to, 8,300 minus 700 and 7,400 minus 3,600, and challenge them to do the calculations with little or no writing. Remember, you can use number facts that you already know to help you. Learners may find this hard, but it is an excellent way of strengthening their mental capacities and number concept. Okay, so here we have questions 10, 11, and 12, and the answers on this side. I'll read through the shaded passage with you. A useful way of forming subtraction facts that you do not know yet is to fill up to the nearest multiple of 10 or 100 or 1,000 or 10,000. For example, if you do not know how much 1,200 minus 700 is, you can ask yourself, how much should you add to 700 to get 1,200? To answer this question, you can first fill up to 1,000 and show your thinking like this. So to get from 700 to 1,000, we add 300. And then to get from 1,000 to 1,200, we add 200. Then you would add those both up. You would add 300 plus 200 to get 500. We'll get there now. So we needed to add 300 and 200 to get from 700 to 1,200. So now we know that 1,200 minus 700 is equal to 300 plus 200 is equal to 500. You may think of this as a movement on a number line. So to get from 700 to 1,000, we add 300. And then to get from 1,000 to 1,200, we add a further 200. So then 300 plus 200 is equal to 500. You can also think of 1,200 minus 700 as the distance between the points 700 and 1,200 on a number line. If you do use a number line in the question, like it says here, remember, draw it freehand and without using a ruler. So literally all you want to do, okay, I don't really have enough space, but you would draw it like this. And then you would have your 700 here. Mine only looks really straight because the computer made it straight for me. I didn't try and make it very straight. And then we'd have a middle point here somewhere of 1,000. And then we could do our little jumps from 700 to 1,000, adding 300, and then adding another 200 from 1,000 to 1,200. Oops, not 1,000, just adding 200. And then you would add up these purple parts. 300 plus 200, which I did over here, to give us 500. Okay. Okay, I think I'm going to pause the lesson here, and then I'll come back with part 2 of this lesson soon, and I'll follow on from exactly where we stopped.